Hello again, and it's our pleasure to start our session two of our webinar during the International Day of Clean Energy, 26 January of 2025. And this session two, we have our five dear speakers. We will start with Mr. Carlos Oliveira. He will talk about the new technologies for wastewater treatment and reuse, the less chemicals, less power, and less emissions, CO2. Carlos Oliveira, he's CEO of Fintel Aqua. Carlos has pioneered advanced wastewater treatment technologies since 1997. He is an expert in oxidation processes and lean industrial production. He is committed to delivering sustainable water solutions with minimum chemicals and energy use. Our dear friend Carlos, you can start, and the mic is yours, and share your presentation.
Thank you very much. Thank you all. It's an honor to be in this forum, and we show our deep appreciation for the opportunity to talk about these subjects. I have the tough responsibility to bring another subject to the table, which is water. So we mentioned a lot of energy technologies to facilitate our future life, but most of them include also water as a part of the process. So hydrogen needs water, nuclear energy needs water, power plants need water, and we even talked about wastewater treatment plants related to energy. So let's hope I can take your attention to the water issue and explain why water is so important in this water energy collaboration. Today, the world and the industry face different challenges regarding water. As from the theme of my lecture, reducing costs, reducing CO2 emissions, and reduce chemicals are one of the biggest challenges in the water world. The big treatment plants are all of them huge consumers of chemicals. They are huge producers of CO2 because if you want to take organic matter from water, we have to convert it into CO2, so there is no option. And they are huge consumers of money because we need energy, we need a lot of components, we need a lot of operations. So all these subjects are on the minds of wastewater treatment plant managers on a daily basis. But there is also a big challenge on compliance and treatment improvement. One has to be aware that unfortunately, most of treatment plants around the world either do not comply even today with the actual legislations they are required to comply with, but for sure they will not comply with future legislation coming out in the near future. Europe is a very good example of that problem, but those problems will arise all around the world by imposing new reject limits into special chemicals, into emerging contaminants, into nutrients. So I would say more than 90% of actually running treatment plants will not comply with the near future requirements. So this is another big challenge that the water world is facing nowadays. And finally, and as we are in GCC area, reusing water, lack of water, the water scarcity are challenges that everyone faces. There are countries around the world which I've been in and know that have available water, but are facing water quality scarcity also. So when we talk about water, it's not only the fact that there is or there is not available water on the ground or around us, is the fact that the water available might not be good enough for our use. So all these challenges and also integrating with the UN goals for sustainability, they drive the attention of today's water managers around the world. When we talk about reducing costs for water production, obviously power consumption is one of those costs. So this is a game between having water or reducing power. But what I want to talk to you about today is the fact that we can improve our water quality, and at the same time, we can improve our energy consumption. We can reduce our energy consumptions by having different strategies. And one of those strategies is on chemicals use. Reducing chemicals use in water treatment is a immediate step into reducing power consumptions and also enabling a better water quality for the future. So I will explain you how we can address this challenge by reducing chemicals and obviously at the same time reducing waste production or sludge production from those chemicals, and even reducing the footprint associated with the water treatment plants. So that or those items are all together in the challenge of reducing costs in water treatment operations. On the other hand, we have to increase compliance. And to increase compliance, we have to eliminate a lot of new, what we call the emergent components or contaminants, and what we call the forever chemicals. Nowadays, people related to the water market know a lot about what we call the PFAS and the PFOA contaminants. So these are polyfluoride components that exist in basically everything we deal with nowadays. And these are a major concern and an increasing concern in water reusage today. So these emerging contaminants need to be removed. To remove them, we should say maybe we need more power. So the challenge is to reach these new quality levels in water and at the same time reduce the power consumption and reduce chemicals consumption. So tackling these contaminants in water and at the same time ensuring that water treatment plants comply with all requirements, either for environmental reject or for surface water reject, or even for reuse. It's one of the big challenges we are facing today in the water world. And reducing water consumption brings us to the reusing water or treated water. And reusing treated water requires other concerns and other challenges. So all these are interconnected, because if we want to increase compliance and if we want to remove emerging contaminants and forever chemicals, that means we will also make it easier for reusing water at the end of the day, because the equipment or the systems that we used for reusing waters, and all of you have heard about membranes and filters and all these type of appliances, they run much easier and more smoothly if we have a treatment compliance that increases the chemicals removal beforehand, because it makes much easier for those systems to prepare water for reuse and for drinking. So we hope we can. Sorry, you are not watching my screen?
No, the screen is not sharing.
I was asking Mr. Antonio.
Oh, sorry.
I asked him why there's no presentation. I thought it's just
Okay.
introduction and you will start the presentation.
So it's now okay? Is okay now?
Yeah, it's okay now.
Sorry for that.
It's
So
fine.
That means these three items can be interrelated altogether, and systems can run much more smoothly. For you to have an idea on when I say reducing chemicals, for you to have an idea what it means, a very short indication of what we use today as major chemicals for water treatment. So what you see, PEC 18 or aluminum polychloride, ferrous sulfate, and ferric chloride are the major chemicals used for water treatment around the world, either for drinking water or wastewater. And these chemicals are used in huge quantities and huge amounts all over the world. And for you to have an idea of the importance of this, only 10 to 20% of these chemicals are active products. The remaining 80 to 90% of these products are just waste that we are putting into water, and which makes more difficult to reuse water later on, and the cost associated with these chemicals, either in fabrication, shipping, stocking, dosing. So all the energy associated with these chemicals is being lost because only 10 to 20% of the product is really active product that brings us to a different water quality. So when we say reducing chemicals, is the fact that our company has been struggling along these years to develop technologies that will allow you to have a different approach on the water treatment sector all around the world. We have today around 25 international patents that comply different technologies to allow for these applications, and these are not just lab systems. So I'm bringing you just two of these technologies. One is the electrochemical or electrochemistry technology, allowing water treatment through energy, through electricity. Another one is ozone technology. So both electricity and ozone are, I would say, available utilities that we can use on optimized applications, and will allow us to reach those new levels of treatment by reducing energy consumption and by making it easier to reuse water. These technologies alone allow you to reduce chemicals almost by 80%, allow you to reduce waste production, sludge production, reduce the need for pH neutralization, which is a normal operation into water treatment, reduce the salinity of water, because when you're using chemicals, the 80% of non-useful chemicals are just increasing the salinity of water, and then you need to remove that salinity to reuse water. So by not increasing it, you can reuse water more easily, and you are saving energy, you are saving money. And all these technologies have a relatively low payback time compared with the conventional equivalent technologies that are in the market today. So we have an opportunity to move into these new technologies, and mainly the opportunities are on revamping and retrofitting existing plants by introducing these technologies, are in increasing the actual plant capacities and not to replace them with new plants. So by increasing the capacity, you are reusing facilities and you are reducing the need for investment and for increased power consumption. When you are applying these new technologies, you can remove persistent and new contaminants from water. And this is a challenge that the world is yet to wake up to these challenges, because these are new requirements that will flood the market very shortly from all water authorities around the world. And then obviously you can, through these technologies, remove much more than the conventional technologies allow you today. So My appeal is that around the world, people can look to these new technologies and understand that the world needs this to move forward and to reach these new targets and this new level of water reuse. I'll give you some application example just for you to understand that we are talking about something that already exists in the market, and it's not just lab technologies. So examples are common sewage treatment plants, municipal sewage treatment plants that can be retrofitted by introducing these technologies and by increasing the capacities. And instead of replacing existing treatment plants, we can take the opportunity of using existing treatment plants and increase their capacity to treat. Also, we do have the landfills leachate, which is a problem around the world, a common problem in every country. We were talking just before on waste production and waste burning, and landfills are a huge environmental problem related to leachate or to water drainage. So these technologies allow these landfills to improve their environmental footprint in order to remove a lot of the contaminants that usually cause troubles on landfills. Okay, drinking water in GCC area, drinking water treatment has some challenges, namely on silica removal, because silica attacks the membranes and blocks membranes, clogging the systems. So by removing silica, you can improve the membrane's lifetime, and you can reduce the power consumption required to desalinize seawater. So this is another example where these new technologies can improve your performance and can help existing facilities to reduce power consumption and to eliminate some of the contaminants. In oil and gas industries, applying these non-conventional technologies can leverage the efficiency of existing systems and reducing the contamination of wastewaters and allow for water reuse afterwards. So all these elements already exist, as well as in other applications like shopping malls, water reuse, textile industries, automotive, detergents, food, industrial wastes. So a lot of plastic recycling, chemicals, all these are industries that exist around the world and that face these challenges of, at the same time, improve compliance and reduce power supply. So I hope this is good enough to raise the awareness on these problems. And again, I appreciate the opportunity to bring the water subject into this forum. Thank you very much.
Thank you, Mr. Carlos. Of course, it's very important, to talk about the water because we consume a lot of power to produce saline water. So water is one of the main issue in the energy transitions as one main element also. Thank you, and we are so excited and interested about your patents and some projects. And maybe we can learn more about it later on, inshallah. Thank you, Mr. Carlos. And now we can move to our second speaker. Second speaker is Miss Osta McKendrick. She will talk about visualizing your asset, the walk before you can run, or walk before you can run. Miss Oster, she's a sales director at Zinc 360, which is ZYNQ 360. She specializes in transforming asset management through advanced visual data solutions. With a decade of global experience, she fosters strong client relationships while delivering innovative technologies for the energy and chemical sectors. Ms. Osta, we are glad to have you with us in this webinar. The mic is yours and you can start your presentation.
Perfect. Thank you so much, everybody. So good afternoon, panelists, attendees, industry leaders, and innovators. My name is Austin McKendrick, and I am the Sales Director for a global asset visualization software and services company known as Zinc 360. It is truly a privilege to speak here today. So thank you to the organisers and to all the other participants. It has been a great conference so far, and I'm delighted to have been asked to be part of it, especially with the Middle East being a region that is rapidly positioning itself as a leader in the clean energy transition space. As we embrace the shift towards sustainability, one of the most powerful tools at our disposal is the integration of digital technologies, as I'm sure you're all aware. Specifically asset visualization and the creation of digital twin ecosystems. And that is exactly what I'm going to focus on for this time slot that I have today. So thank you. Imagine being able to see every detail of your clean energy asset, whether it's a solar farm, a wind turbine, or a biomass facility, not just as it was designed, but as it is actually built, or what we like to say in real world context, with every operational nuance at your fingertips. This is the power of asset visualization. So this is exactly what we offer at Zinc 360. We create real world digital twins of different assets, and then we deliver them within a cloud-based collaboration platform, and that cloud-based platform is Zinc. But as I'm sure you're all aware, there are many tools and applications out there available, and it's a very growing industry. I'm just going to play a short video next, just to give a little bit of an insight. So by digitizing every component of an asset, we can create a highly interactive, detailed representation of any physical infrastructure. So this means better monitoring, reduced downtime, and insights that allow us to act preemptively, avoiding costly failures with a well-integrated visualization ecosystem. You aren't just managing your assets, you're being able to elevate their performance and unlock efficiencies and empower those in the positions to make decisions with better clarity. So this slide here is just showing a little bit of how we position ourselves with our software or any other visualization software. We believe that it should sit at the foundation. So no matter what your asset type, it really can be asset and sector agnostic. And you start with a basic level visualization. So the real world capture of the asset, it's uploaded, ingested into the software, and then you can start really enriching that digital twin with lots of really rich information. So you want to tie in things like asset registers, equipment registers. If you're using a platform like SAP, I know that was shared earlier in a presentation. We don't want to replace anything that's in other systems, but we want to try and bring it together so that, at the fingertips of those, they have all the information that they require. And to do this, we can start to ingest information. We can do direct links, so linking one platform to another, or we can do full-blown API integrations where maybe a window would pop up inside of one platform and it would share detailed information that is relevant to what you're looking at. And this slide here talks basically what the purpose of my presentation today is. So with the new technologies entering our space, and there's lots of visualization and there's lots of buzzwords, digital twin, visualization, and then the different types of visualization that people might use. It might be 3D models, it could be drone. So it can all be quite, I guess, intense, and people in the industry can maybe feel a little bit overwhelmed. So when we talk to customers, we want to take this phased approach, and that's what you can see here on my display. When you talk about the pink circle, which is fly, that's all these buzzwords that are talking about automation, autonomous capture, AI, machine learning. People have grand aspirations to get to these technologies and be able to use them in their day-to-day lives and their day-to-day asset or maintenance management. And that is fantastic to have those aspirations, but you have to start somewhere. And most of our clients, I would say, are probably on the walk phase, even ones that we've had for many years, because it is actually such an undertaking. So when you look at crawl, you want to start with a simple data capture. So maybe going out and using maybe a SLAM device, which is a wearable device that enables a much quicker capture. You can walk around the facility or the asset and you will get decent enough imagery, but then you'll also get reasonable, measurement capabilities and things like that. So that would be a good base level. And then from there, you want to make that data available to everyone within the workspace. So it could be a huge global organization, or it could be a smaller regional organization. But what we want to avoid is different departments doing things like laser scanning for a particular project, and then they take that data capture, they put it into a drawer or they file it away, and their budget paid for it, so they don't want to share. So what we want to do is open that up and make all this visual data available to as many people as possible, and almost like crowdsourcing to share that information. So everybody uploading their information, having it on that collaboration platform, and then when things need to be changed or updated, you're using that crowdsourcing mentality to make sure that things stay up to date. Because with any data capture that you do, whether it's laser scanning or photogrammetry, it is actually only a moment in time, and you have to have something baked into your process that's going to help you maintain and sustain that data capture going forward. Because if the data isn't up to date or as much as it possibly can be, your users and your employees are going to lose faith in the data, and then you won't have that strong adoption. So this leads me on to talking about the right tool for the job. So it all plays back to the crawl, walk, run. So when we're starting out that journey with a customer, or if you're considering starting your visualization journey out, you want to have those conversations internally and determine, what is our asset? What does it look like? What's the size? What's the risks and the hazards and the complexities? We have some customers who, not so much talking about clean energy, but they run agrochem facilities. So very complex, very dangerous, very high risk environments. So we have to take consideration to the folks that are going out onto site. And if we can reduce those site visits with really high definition imagery so that they can get into those areas without having to wear the PPE and expose themselves in that way in those environments, then we might use something like a photogrammetry. So once we understand what the asset is like, what the use cases are, and then what type of accuracy levels do you want within the data capture that you use. So when we talk about data fidelity, so when you want to fabricate, for example, we would maybe recommend a laser scanning or a SLAM, depending on what levels of accuracy or measurement that you require. But often enough, we actually use a combined method. That's typically what we do. So we'll do something like a SLAM where we wear the wearable kit, we go out and we walk around the site, we understand what areas are required to be captured. We start at that base level capture, and then from there we'll send maybe a drone out, so then you've got the overview bird's eye view of the facility or the asset or the plant or whatever it may be, and then we start to stitch those together. So there really isn't many dark corners. You're capturing the entire facility and asset, using the best or the right tool for the job to ensure that you're well prepared for your current and future use cases. And then the impact of zinc. So what we're trying to do is elevate that digital transformation. We have many customers all around the world. We work, very predominantly in the energy sector, but we dive into other areas as well, and we're very much sector agnostic. So you will find that we have the typical use cases for the digital twin ecosystem and what they're accessing this real world twin for. So it's just general operations, maintenance, planning, inspections, remote engineering, turnaround and shutdown planning. But then we do have different use cases coming up all the time with our different customers. Our customers that have adopted our software, they're very proud that their teams are fully immersed in their digital twin, and they're always looking for different ways in which to use the twin and the data. So really providing your staff or your potential staff a truly immersive experience when it comes to training and familiarization. So when they're going out to do a job, part of that pre-planning would be to immerse them in what is to be expected when they come onto site. So they are prepared before they go. And then other things like incident investigation. So we've had some instances where we've had some customers who've maybe had an incident on site, and maybe a fire perhaps, and they had the capture done beforehand, and then they've had a fire. So then for insurance purposes and just for incident investigation purposes, they were able to use that twin to go back and sometimes retrace steps on what could have happened on the incident, but also just to go back and rebuild what was there before, and then to renew following something like a fire. So there's definitely many, many use cases, and the more use cases you can find within a business, and the more that you open it up to not just one department or one project, the quicker ROI you're going to see and you're going to find across your business. So yes, for clean energy leaders in the Middle East and around the globe. This technology is more than just innovation. It's a competitive advantage, and it drives sustainability, and it enhances reliability, and it ensures long-term viability. So, we've just got some typical uh, um, ways in which the digital twins can improve your day-to-day business, all those that you can imagine, and those that everyone in the C-suite would want to see. So, saving costs is a huge one, reducing downtime, reducing risk, ways in which that you can reduce your emissions. So one of the things that you could tie into your ecosystem would be, if you had another software or a solution that was reading emissions, you want to tie that into the visualization. So you can say, okay, I have emission reading software here. Where is that on the facility or the asset or the plant? And then, travel to and around assets. We have different, like I say, different clients, and they have different challenges that they face. But you might have something like maybe wind turbine farms, and they're maybe quite vast and they're spread out, and you want to use visualization or drones to go out and surveillance the areas, rather than sending someone out in a truck or a vehicle to drive to and around. Just the savings and the time, and obviously the hazard and risk for that as well. Improving safety, definitely improving collaboration. We live in the big world, and even through COVID and just the adaptation of things like this, these conferences where we're all collaborating around the screen. I'm in Scotland, some of you guys are in Kuwait, some of you guys are maybe in the US, all around the world, and we're all coming together to collaborate. So if you're running an asset and your offices are spread all throughout the world, what better way to be able to visually see what's going on as you guys are discussing on a call or planning for your next big project.
Yeah.
Definitely improving the
Sorry to
decision
say
making
that.
on that.
We have 1 minute. Sorry for that.
Okay, no problem. I'm just about to wrap up, and then remote access and remote working, like I mentioned, with things like COVID. So yes, I'm just wrapping up. So that is it takes me to my last slide here, guys. Why Zinc 360 and why visualization. I think that some of these areas are very important on the screen, to touch upon. And as the Middle East embarks on its clean energy journey, embracing tools like asset visualization and digital twin ecosystems, leveraging those technologies can really optimize resources, anticipate challenges before they arise, and ensure that clean energy investments are smarter, more efficient, and future ready. So, definitely working together, we can build a sustainable future where technology doesn't just support clean energy, it accelerates it. And I will leave you guys with that thought for today. Thank you so much for the time, everyone, and I really appreciate you listening to me for the last section.
Thank you. We appreciate your participations, and you are talking about one important issue, which is the asset management. And when you have a good tool that will help you, to achieve your economic goal for any projects. Thank you, Ms. Osta. And now we'll
Thank
move
you.
to our next speaker, Mr. Manuel Lemos. He will talk about addressing challenges and opportunities for GCC grids. Mr. Manuel, he is the CEO of Inline. Manuel brings over 15 years of experience in energy systems, formerly with Mota Engel Energia and Voigt Siemens. He leads innovative grid solutions to enhance GCC energy infrastructures. He is also a non-executive director at HydroPlus Global. Mr. Lemos, we are happy to have you with us. The floor is yours, and you can start your presentation.
Thank you very much. I wish you can hear me well, right? Okay, very well. My name is Manuel Lemos. I'm CEO of Enline. I'm calling from Lima Airport in Peru. Sorry for the noise if you are listening some noise in the background.
That's
I'm Portuguese. We have a office here in Peru, and this is the reason why I'm here. Now I'm flying to US. In GCC, we are represented by InnoEnergy, and is a big pleasure to be with you today. I have a presentation and a video to show. I will share my screen now. Okay, let's start by the video. Is a company presentation video. Is only 2 minutes.
There is over 100 million kilometers of transmission lines, providing energy for millions of people worldwide. By 2050, the increase of global energy demand will be up over 47%, challenging the industry to provide a more reliable and sustainable service. N-Line is providing next-gen solutions for power monitoring and optimization. Our sensorless, AI-driven digital twin technology is the answer to the growing needs and challenges of the energy sector. Our unique technology replicates the grid's behavior with real-time data, with over 95% accuracy, and uses AI and machine learning techniques to optimize its power efficiency. This unprecedented cost-effective solution allows us to predict faults and critical events, increasing the resilience and reliability of your energy infrastructure. We implement our solutions completely remotely, anywhere and anytime, up to 12 times faster than traditional technology, without deploying additional physical sensors or requiring shutdowns for installation. N-Line's proven track record shows significant reductions in costs, outages, energy congestions and losses, and increases in data accuracy and fault detection. Whether it be design and construction, monitoring and maintenance, or future-related operations, we have software applications to address the needs of a wide range of industries and customer types. We continue to increase our presence worldwide, providing cutting-edge solutions aligned with the global goals for sustainable development. N-Line's work and experience has been recognized through many awards by the most knowledgeable institutions in the sector. All of this is possible thanks to our international team of software experts, power system engineers, physicists, mathematicians, AI data scientists, cybersecurity experts, and many more industry professionals. We invite you to join the next digital revolution with N-Line, powering the future today.
Okay, I hope you can both see and listen well. Now I'm sharing again. Okay. Very well. We will talk a little bit now about the GCC grid, some of the challenges we identified and opportunities. I hope you can listen to me well, okay? If you are not listening, please let me know. This is a short presentation, and let's start. First of all, a little bit about historical context. These grids are been facing many challenges. We saw a very fast population growth since the 90s. Just to give you an idea, the energy demand grew almost 10 times since mid of 80s, and the energy grids, they were built decades ago, and they are now getting some limits of lifetime, some limits of capacity, and they have also aging effects. The challenges are multiple. First, these GCC countries, they are investing in renewables, and they want to integrate renewable energy in the grid. Second, with climate change and global warming, we see more and more extreme weather events, not only heat waves, but also extreme weather events like rain and extreme winds. Also, we spoke about population growth, and this population is keep growing, and people are demanding more and more energy, including even the EV vehicles and the electrification of the industry. And we are seeing in the last years and months more and more power failures and blackouts. And the question is, what if we do nothing? What will happen? And the answer is very easy. We will see a fast degradation of this infrastructure. We will see more failures. We will see more power cuts, and we will understand the operational cost will rise. And the solution is to build new lines. There is any other solution? Yes. Before we build new lines, because new lines are important, but we don't need to build new lines to solve all kind of problems. New lines, they must be built in the last case because they take time. A project of a new line can take between 5 and 10 years from the first idea to the final, let's say, commercial operation. They are very expensive and they don't solve problems and they are not viable and not sustainable. We need to think about alternative solutions. And the alternative solutions are basically based in the digitalization of the system. The creation of and implementation of digital solutions like the ones we supply, we can solve most of existing problems without the need of building new assets. The big difference is that we can implement digital solutions like the ones we have in a matter of hours or few days. And we can, just to give you a reference, create 2,000 kilometers of power lines, digital twins, without the need of sensors, without the need of traveling. Everything is remote, and we can build 2,000 kilometers in few hours with a very small engineer team. This is the big revolution we are bringing to the market. And these systems that we supply to different companies around the world, we can apply at different stages of the project. We can apply at the planning stage, at the engineering, to optimize CapEx, to optimize the resilience of the project, to make it more, let's say, better prepared for the future. But we also implement solutions for monitoring on operations, from dynamic line rating to increase capacity of congestion transmission lines, short-term overload to increase maximum peaks in the peak hours of demand, optimal power flow to reduce losses, power optimization, vegetation management, fault location, predictive maintenance, many modules that we can sell and we can implement very, very fast without need of traveling, no sensors, no drones, no site works, everything through internet, cloud-based. And this is the revolution in line brought to the market. This is almost, let's say, a vision of the future. For many, many years, this was impossible, but now it's possible. And we have many, many projects around the world, and even starting some of them in the GCC area. And how this works, just to explain, we use existing data. We use existing data, and we use science. We use the existing knowledge and formulas from the mathematics, from physics, and we use existing data from the customer. For example, data from the towers, from the conductors, from the isolators, from the transformers, location, type of soil, weather data, satellite images, and we create a digital twin based in the cloud, and we can deliver many outputs from real-time and predictive monitoring. We can see optimization of the operations. We can protect the assets. We can optimize design, and this is very unique. And explaining this technology in three main words, I can start by the sensorless electromagnetic modules. And this means using a cloud-based solution using internet with a IP owned, intellectual property owned technology developed by us. And using science, we can create these digital twins, and they are live digital twins. They are not static. We can just see all electrical, mechanical, thermal, weather variables in each part of the asset, meter after meter. Second, the data science and AI. This is quite important. AI is huge, and the potential of AI is huge. And why? because AI bring us many information, especially for predictive, and we can understand the behavior, we can be prepared, we can make simulations, and AI and data science is super important in our construction of our modules. And last but not least, we have these 3D replicas with a very, very high accuracy, 95% accuracy above, even when we were compared with sensors implemented in the site, and we can see everything that is happening, historical data, real-time data, and predictive data. And here I give you two main case studies and examples of real customers. The first is in Spain, Red Eléctrica, the main TSO in Spain. And here we started with small lines. Now we have 6 transmission lines, and we are solving problems like dynamic line rating, vegetation management. And we increased almost 30% the transmission capacities of congestion transmission lines in Ibiza during summer, peak of demand and very high temperatures. All the lines were congested, and we solved the problem. The impact is huge, more than 100 million euros per year, and many challenges, but the solution was implemented very fast and is working successfully. And the second is another example with a TSO in Finland that we started with 50 kilometers, 400 kV lines with a huge impact. And now we are implementing the next stage that is a tender for 6,000 kilometers of a total of almost 15,000 kilometers. And these processes we implement in very few days, is super fast, super competitive, and we don't have competition at this level. And this is a revolution because again, we are not using sensors, we are not traveling, all the process is remote. Is really a big revolution in the way we can digitize power grids. This was my presentation. I would like to thank especially to Antonio Campos and to InnoEnergy that represent us in GCC countries. It's a pleasure. I ask you, my apologize if my connection and sound is not the best, and I'm very open for your questions if you want. Thank you very much.
Thank you, Mr. Manuel, and we wish for you the safe trip. It's really interesting presentation, especially when we are talking about the smart grid. These things is very valuable, and of course, and I think our audience enjoy the presentation, and inshallah we'll see you inshallah next time when you inshallah will be when you come to GCC inshallah in the future. Thank you, and now
salam alaikum, and see you soon.
Have a good time and trip. Thank you. Bye bye. Now we are moving to our dear friend Engineer Hani Balbas. He's going to talk about transmissions as a key enabler of energy transitions in GCC.
Hello, Assalamu alaikum wa rahmatullahi wa barakatuh. Good evening, all.
Alaikum salam. And can you allow me to introduce you, Mr. Hani?
Yes.
Allah
Yeah.
Engineer Hani, he's a general manager of renewable lab in GCC lab company. He's a renewable energy expert specializing in solar PV testing and grid integration. With advanced degree in solar engineering and vast technical knowledge, he contributes to shaping GCC renewable energy standards. It's our pleasure to have you, Mr. Hani, and you can start your presentation. Thank you.
Thank you very much, Engineer Salim. I would like to extend my appreciation to Ms. Ghada, Her Excellencies Ms. Ghada, for her presentations, and for you, Engineer Salim, for organizing, and Mr. Anthony, and our panelists and the audience. Thank you very much for attending and having this time. It is our pleasure, really, to present what we have experienced in the market or in the industrial. So today I will talk about the transmissions as key enablers of energy transition in GCC countries or in GCC area. Uh, yeah, the agenda today will go a little for general background about the energy transitions, then the energy dilemma in GCC and MENA region, energy transitions programs that we have in the territory, and challenges and solutions. Then the expected impact for this kind of transitions. Let's say we had been surveyed during COP28, which is the climate change conference that had in Dubai 2023. The survey shown that over than 62% of executives expected the world to reach net zero emissions by 2060, and that increased. It was 54% last year's Ben survey, and the energy transitions looks slower as it is become even more difficult to ensure investment returns. That's the survey shows during 2023 conference. The international potential for the energy transmissions in 42 economics. World Bank has pledged 45% of its annual financing will be directed to the climate-related projects for the fiscal year 2025. As well as the international financial corporations estimated that by 2030, supporting low carbon investment will be generate more than 10.2 trillion investment opportunities, will create over than 213 million jobs, and reducing green gases emissions by 4 billion tons. So it is great and huge potentials. The dilemma for the KSA and GCC regarding the energy. We will talk about the hydrocarbon export contribution to GCC to GCC economic, like Saudi Arabia exported hydrocarbon in 2021, 60% from their exportations, and UAE between 80 to 84, Kuwait 80, 84, Qatar 80, 84, Oman 74, Bahrain 63. It is obviously that more than 60% of the exportations of the export products is from it's including the hydrocarbons. Non-hydrocarbon export growth for KSA, the non-oil sectors growth has accelerated, reaching 4.8% in 2022. UAE was expected to grow by 5.8 in 2022. There is lots of challenges in energy transitions in the area. Let's say oil prices and demand decreasing globally, resulting in fiscal challenges, significant increasing in the internal energy demands due to modernizations projects like in Qatar, in Saudi Arabia, Kuwait, Emirates, Bahrain, even Oman. Sustainable energy in the region provides non-economical justifications due to the low prices of the oil. Fossil fuels have been the largest contributor to green gases emissions. This is one of the main challenges for energy transitions. The greenhouse gases emissions in the area is the highest globally. Like, let's say the global ranking, the first global ranking, Qatar, is emissions per capita is in 2021 is 35.59. We expected that because the 2022 World Cup project and modernizations for the events. Bahrain as well, the second, Kuwait the third, let's say Emirates the sixth, Saudi Arabia the eighth, Oman is nine. So the country, the GCC is the main is in the 10th of the first global ranking for emission, CO2 emission. Energy transitions programs that's planned and approved in GCC. For carbon circular economy, Qatar, Saudi Arabia, Emirates have accelerated investment in CCS facilities. Currently, they capture approximately 12% of global CO2. Saudi Arabia has green initiatives to plant 10 billion trees in the country, and there is Middle East green initiatives will plant 40 billion trees in the Middle East. This is one of the programs that approved and accelerated. And Saudi Arabia is investing around 1.2 billion in green building, and it's retrofitting around 90,000 mosques to to be a green buildings in this kind of issues. GCC energy transition programs. There is net zero target for GCC countries. Saudi Arabia 2060, it will be the programs and the target to be net zero. United Emirates and Oman 2050, Bahrain, Kuwait 2060. The program includes, all programs includes for the GCC to support of low carbon technologies such as green hydrogen. This is one of the main program that governments of GCC support. Circular carbon economy, obviously, and increasing engagement with carbon market. This is obviously for the main companies in the GCC, and domestic energy efficiency initiatives. For renewable energy penetrations, there is targeted energy mix. Saudi Arabia will have the target 50% for the energy mix by 2030. UAE 44% by 2050. Oman 30% 2030. Bahrain 20% 2030. Kuwait 15% 2030. Qatar 20% 2030. So in 2021, renewable energy forms are almost 1% of energy mix of GCC states. So that show us in just 10 years, the GCC governments, they have serious steps to reach their targeted, inshallah, in 2030 or 2050. For green hydrogen, there is lots of advantages. No emitted the greenhouse gases when burned. Can be produced from green sources and can be produced from water. So that show us is like it's the main sources, the main green sources is the green hydrogen, and there is lots of programs to produce the green hydrogens. Oman, Saudi Arabia, and UAE take the leads as the main nine projects in the area for these countries. I can say in 5 years, Saudi Arabia will spend more than $19.4 billion for producing green hydrogen. Oman $14.5 billion for same productions, and UAE $10 billion. So the GCC transmissions for energy, they take serious steps. Inshallah will be achieved in soon. There is for sure challenges and for sure solutions. One of the challenges is high upfront cost is obvious. Meeting net zero commitment will require increasing funding. And ROI challenges are increasing. يعني net zero commitment needs increased funding and the oil pricing goes down. So it is kind of challenges. طيب the solutions يعني kind of solutions to collaborate with investors and financial institute to encourage the creation of innovations financial programs or products. Increasing grant funding or enable debt financing without requiring government guarantee. Yani this is this is two solutions. Industrial leaders believe generative AI has the potential to improve the AI we should using in this transitions to improve maintenance, production, supply chains, and among of the area. يعني this kind of study, if we use AI, would be significant impact of these functions, like improving maintenance will be 70% of improving maintenance, production optimizations 58%, supply chains 54. These studies or these assessments show us how important to use AI to reduce cost in energy projects. One of the challenge to the stakeholder engagement, we need participation from all stakeholders, public, private, regulators, and institutes to promote social dialogue, partner across sectors to scale new ventures, create sustainability, employment, and development opportunities. One of the challenges to driving equitable employment. So the energy transitions will create 30 million clean energy jobs by 2030, 30 million jobs. That needs new skills to sit and specializations. Measure and policies will be included to minimize the impact to worker livelihood. So this is challenges, yani solutions kind of to develop sustainable academic and certification program for this employee incentives program to employ affected communities worker, motivate global experts movement to the territory. This is I know Saudi Arabia and UAE use move serious steps in this kind of motivation. The supply chains challenges had we know about the COVID-19 how it affected the supply chain, and the wars happened worldwide affected the supply chains. There is risk associated with the supply chains, chain volume storage, price volatility, sourcing dependency, long lead time, quality, all these challenges for supply chain. One of the solutions of the supply chains to enable the local or localizations programs that will positive impact on the national GDP. Approximately 65% of global customers would prefer products made in their country. Geographical proximity, time zone alignment, shortest lead time, and better service delivery. This is advantages for localizations, job creation, easier to travel to support and meetings, low cost for logistic. So what is the impact expected if the GCC move for energy transmissions? Expected impact: GCC states GDP to jump up to 13 trillion by 2050 for all the countries, GCC countries, accelerate their economic diversification, reduce domestic demands on fossil fuel, boost localization initiatives for proper security, and cut greenhouse gases emission by 278 million tons by 2030, pioneering clean energy, climate technology, and innovation. That's for today. And again, thank you very much for all the audience for your time. Thank you, Mr. Salim.
Thank you, Mr. Hani. We are so pleased about what you mentioned about the energy transitions in GCC. You gave us and to give the audience the clear spot about it. I think they will like to know more later on, inshallah. Now I think we have, I know we are run of time, but we have two questions. We can receive them from the first one from Jawahir, and the other one is Sulaiman, and then we can conclude our conference. Jawahir, can you remove the mute? We can continue with Mr. Sulaiman if he is ready. Sulaiman. Okay, since none of them is ready, so it's better. Okay. Good. So I think, Mr. Antonio, we reach the end of this conference. Very interesting.
Let's just, sorry to interrupt. Let's just make a explosive question to this group of panelists. Since we mix water with the energy with the technology, so I think we are in a good position to mix and ask briefly what are the perspectives to integrate on the clean water solutions? What are the expectations to integrate these new technologies, the AI, the digital twin, as we listened from Austa and from Manuel and from Annie, on the importance of integrating all these new technologies in order to get more efficiency, in order to get more sustainable energy. Just a wrap up from them.
Yeah, we
One
can.
minute, 1 minute for each.
Yeah, no problem. We can start with Mr. Carlos since he's in the spot.
In the water business. Thank you. Actually, the water treatment systems will become more and more complex in a short time. So, because as I mentioned in my presentation, requirements and specifications will be more and more stringent. And the way these technologies become more complex, obviously, having tools to help dealing with them and manipulating them and getting all the data out of them and managing that data is of paramount importance. So I would say AI, mixed reality, all the tools we can gather in order to help people managing these systems and getting the best out of them are really very useful. We as a company, we already use AI in some applications on detecting the quality of water after a process treatment. But then we have all the utilities and all the equipment that are related to the water treatment system that need also to be controlled and to be guided and to be maintained. So there is a whole lot of applications, potential applications of all these technologies, but mainly data gathering is nowadays one of the biggest spots for research as these systems are becoming more and more complex and large.
Mm. Yes, and who wants to add, Ms. Austin, maybe the asset management is important also in all projects, and wastewater treatment is one of them, to keep up the quality of piping, and even the water, how quality. These all things should be tracked by somehow, which is the zinc can play a great role in that.
Yes, absolutely. And I do think that the future of digital twins in asset management, it's a very promising technology, and adoption is growing across the industries. But there are definitely a lot of buzz words when it comes to things like the enhanced predictive and prescriptive maintenance, integration with AI and machine learning. So to echo what my presentation was really about, it is, walk before you can run, and start with the basics, and then start to really integrate and bring as much information to really enrich it as much as you can. I really do think that they're likely to be the cornerstone of asset management strategies going forward, and they will be driven by these advancements in AI and data analytics. But rather than just that supportive tool, it really is going to be a proactive partner in the asset optimization, and to push companies to achieve their sustainable goals as well.
Mm. Um, yeah, Mr. Lemos would like to add before you go to the boarding.
Yes, no, I'm a hydraulic engineer. Can you hear me well?
Yeah, we can hear you. Yeah.
Yeah, okay. I'm a hydro guy in the energy world, and energy and water, they are already foundations for the society, and they will be much more. And I think water is in the backbone of the society since always. Energy is getting more and more important in the next 50 years. Water and energy will be not only the foundation, but the most important backbones of the society. And now we are bringing something that is quite new, is AI and digitalization that for the first time is possible to do in a different approach, remotely, very fast, very competitive. And we are just putting in the corner, or basically changing the mentality that was related. Digitalization was expensive. Digitalization is based in hardware. Not anymore. Not anymore. Now it's cloud and internet to create digital twins, and this is what we bring. And this is the revolution. And thanks for the invitation. It was a pleasure. And see you next time.
Yeah, and have a safe trip. Yeah. Mr. Hani, do you have any comments regarding the matter?
Yeah, for the energy transition to the clean energy in GCC, it is not a choice. It is not a choice. We have worked together. We have all the stakeholders working hand by hands, aligned, shoulder by shoulders to achieve this matter. For As all we know, there is a shortage of natural water in the GCC, and lots and major, let's say one of the major spending of or let's say CO2 emissions coming from the water treatment energy that's used so for energy transitions to clean or to green hydrogens. It's supposed to have, because one of the major sources is the shortage here in the GCC, which is the water, the natural water. And let's say يعني there is lots of modernization projects and events coming in the GCC in the coming 10 years needs يعني huge waters. That means the demand is increased day by day. I will not say is year by year. It's day by day. So energy transmission is kind of one of the must goal.
Mm. Yes, thank you. And I think Saudi Arabia was one of the leading countries in GCC who producing water from the desalination process by solar PV systems. They have done it in Al Khabji, and you know the water treatment, wastewater treatment can be also utilized by green energy, and also the output of the treated water. Is it in good quality that can be used for hydrogen process, the green hydrogen process? There is like a certain specifications for water to be used in the process of electrolysis. Is this يعني standards or the quality of the water that is output from the wastewater treatment, is it almost the same requirements that the electrolyte or not? This is what we needed to hear it from Mr. Carlos.
Hydrogen production is very sensitive to water quality.
Mm.
So hydrolyzing water, meaning breaking down the molecule down to the H molecule, requires a very pure water.
Mm.
So yes, you can use treated wastewater, but you have to reach a point where that water is basically almost pure,
So you need
so that you can actively and efficiently produce hydrogen.
Mm.
So the highest cost, or not the highest, but one of the largest costs on hydrogen production is actually water treatment.
Mhm.
So of course you're right when you say why don't we use treated wastewater to produce hydrogen? Of course we can. It's just economics right now. I mean, if we can reach a level of water quality that allows for that at a reasonable cost, and if hydrogen production is good enough to compensate for that cost, yes. Otherwise, as I usually say in my lectures and at university, I mean, the water is always the same. I mean, it just goes down round and around. So maybe we should focus more on reusing easy water and then letting the other water just go to the sea or to the rivers or to the lakes, because someday that same water will come back to us, because that's how it works. So we have also to be, let's say, sustainable when we analyze the water cycle, because we have to respect the water cycle. And that's very important into sustainability, not to try to force all reuse and every reuse no matter the cost. I mean, also allowing water to do its natural cycle is also important.
Mm. This is a great issue we need to consider. Mr. Antonio, what do you think now? It's time to say,
To say thank you, first of all, to and for my side and for you, Engineer Solomon, for organizing this event and always promoting the sustainability and promoting the dialogue that and promoting this. I will say that the new energy is this collaboration that we are sharing in this kind of events, in this kind of conference, and without this collaboration, without people, that in the end of the day we are talking about people, this makes the energy sustainable and efficient.
yeah.
And for my side, from Up to Energy side, I just want to thank you again and wish you all the best and a year ahead
Yeah.
promising.
Inshallah, thank you. And next time, inshallah, our conference will be in person or face to face in Kuwait, inshallah, as well as the online. At the end, on behalf of the Arab Union for Sustainable Development and Environment, as well as Quest Sustainable Solutions Company, would like to thank all our dear speakers, especially our the Highness and Excellency Ambassador Ghada Tahir for her support and participation, as well as we are our dear speakers, Mr. Robin Mills, Miss Oana Penu, Mr. Hassan Choudhary, Miss Sundus Bushehri, for the session one participation, and our dear speakers in session two, Mr. Carlos Oliveira, Miss Osta McKendrick, Mr. Manuel Lemos, Mr. Hani Belfast. Thank you, our dear friend, for your time. I know it's long day, but I hope it was not bothering you to be with us. I'm sure our audience they enjoy the presentations and the talks. From for our speakers who would like to share the presentations through Mr. Antonio, it's our pleasure to send it to our audience. For our audience who are interested to the presentations, they can message the WhatsApp number in the post. So we can just add us in the WhatsApp so we can keep in touch for our next event. And also for the certificate, as we promised, is free from Sustainability Institute. So we need just take time to check the attendance list. And again, thank you for being with us, and thank you all, my friends. We can say bye now. Thank you.
Thank you. مع السلامة.
مع السلامة. Thank you, Mr.
Thank you, Hassan.
Thank you.
Thank you. Goodbye.
Thank you.
Bye-bye.
Thank you. Bye-bye.